Good morning.
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 Let's get this show on the road. Let's take this show on the road. Well, what questions have arisen in your mind before I launch into a bit of an explanation of more of 5.3?
I have a homework question, but I don't know if you want to wait till after class.
Ask it now.
One of the questions was kind of weird. It's another one of the G of X of F of X kind of questions.
Uh-huh.
But I got the first two of them right, but I'm confused on the other two because I thought I had it, but then my actions, I guess I got it wrong, and I don't know where to fix it.
Is that a 5.3 question?
Yeah.
Which one? Can you remember?
Hold on, let me check.
The first part of that assignment, and I may address some of these things today, but the first part of that assignment is a little odd in that regard.
Question 3.
Yeah, I do want to talk about that. I'll talk about it in context today instead of just immediately right now. But the first three questions on the 5.3 assignment are pretty weird in terms of what they're asking. So let me lay a little groundwork and we'll kind of go back and look at that. And also, make sure you understand the sort of the main plain questions of 5.3.
There were some that were kind of like just simpler, like find the integral or whatever kind of problems that I thought were kind of difficult too. Like I think it was question 9, I want to say, that like ended up with like dividing by zeros and stuff like that, maybe.
Let me take a quick look at that. Yeah, because I want. Yeah, I'm looking at question 9. Let me just start off with a few random problems that are sort of in this world. It kind of ended at the yesterday, showing some examples of some of the things you might recognize. And by the way, in case I forget to mention it later, which I probably will, I did go into my open math and I posted my Calc 1 notes that tell you all the derivatives, sort of the going forwards. I posted that in, where did I post that in? It was like at the top. I forgot what it was. In course information at the top, the highest block that's in there. So that note sheet's in there. You can either look at it or print it because you're probably going to want to look at that and maybe even right now. So as an example, let's just play around a little bit. So now we've sort of left the theory that got us to this place, and now we're just saying let's take integrals, which again just gives us a formula that produces the area of the original shape. So if I said something like this, I hope you would say, okay, no problem. If I said, what's the integral of 2x squared plus 4x minus 5? I hope you would say by the power rule, that's not so bad. But what if I came in and made a quotient rule problem out of it? This is an example of something you'll see in the assignment today, which is just a slight curveball. Now, if that's kind of quotient rule, you remember quotient rule was darn complicated. And not only was a quotient rule complicated, but we got to go in reverse somehow. And so that feels like, that's not good. But why is this actually easier than that? Why you don't even have to do this as a quotient rule? What algebra do you know here that would allow you to make this problem easier before you even tackled it?
Well, what I did for this one was just move the x to the top by like creating like a negative kind of exponent, but I felt like it made like one of them turn into like x to the 0 over 0 or something like that.
Yeah. In other words, if you take that x to the positive 1 power on the bottom and move it to the top as x to the negative 1, now it's still a product rule question. But notice by distributive law, every one of those is divided by x, and you can just divide every one of them by x. And don't forget, Felix, that x to the 0 is 1. So this problem can be transformed since x squared divided by x is x. So 2x squared divided by x would be 2x. 4x divided by x would be 4. And 5 divided by x would be 5 divided by x. And so now you don't have a quotient rule anymore. Well, except for that last term. And just like, remember how derivatives loved plus signs? Like we didn't mind two equations added together because we could do them separately. We did not like two equations multiplied together because then the product rule came into play. So we love these plus signs and minus signs because we can just do these separately. So the, again, power rule, I say power rule in quotes because we're sort of going in reverse of the power rule, says add 1 to this exponent, x to the first. So I add 1, I get 2, and then I divide by 2. That's the reverse of the power rule. So there's the integral of 2x. The integral of 4x, and to Felix's point a second ago, if you want to, you can think of that as being 4x to the 0 power, because that's what's there is a 1. And if you add 1 to that x to the 0, it becomes x to the 1, and you divide by 1. Notice when you're all finished, you get 4x, and then you think, oh yeah, duh, the derivative of 4x is 4.
Well, it was actually the 5 that was made it difficult for me because it was because I would like just change the x to like move it to the top and change the power to -1, and that made it weirder.
Yeah. So then this last one sort of seems to break because since that last one is really 5x to the -1, then you add 1 to that -1 and it becomes -5x to the 0, which is fine because x to the 0 is just 1. But then you got to divide by 0. And remember, when you divide by 0, it's not so much, oh, that's undefined or it's broken. It's really infinity. Remember, all division is repeated subtraction. If I have $100 and I divide it by 0, that's kind of like me saying I've got $100 and I'm going to give $0 to each person. So how many people can I give money to? Well, I can give money to infinitely many people since I'm giving 0 to each person. So the answer dividing by 0 is actually infinity. Up to now, before calculus, you just say, oh, you know, whatever, it's undefined. But remember, this is a special case from yesterday. Look at that note sheet that I referenced. What's the integral of 1 over x?
Log.
Yeah, log. That's a special case. Like this sort of breaks. Dividing by 0, it really doesn't work. The integral of 5 over x is really just, well, the 5 just comes along for the ride, and the integral of 1 over x is the natural log of x. So there's your integral. Something else you might see, since, and I'd like you to, this comes up in your assignment too. If this expression right here is kind of called lowercase f of x, and then you're all done taking the integral, what are we going to call this thing? Like from last term, from 251, if we said, hey, f of x equals 4x cubed plus 7x, and then we take its derivative going forward, then we'd say, oh, power rule, normal power rule, not backwards. 3 comes down front times 4 and becomes 12. And then the power reduces by 1. For 7, it turns into 7. What do we call that new equation? When we say it's a derivative, but how do we write that? What's the symbol for writing that down?
F prime of x?
Prime. Does it make sense? In this case, we sort of need the same thing. Like, what are we going to call? What are we going to call this? So if I simplify this, I end up with x squared plus 4x minus 5 natural log of x. Just like this was the derivative, this thing is the integral. The fundamental theorem of calculus just says it was the same process that got us both. One just went forwards, one went backwards. But what are we going to call that? Does it make sense we need some new symbol? Does it make sense you could actually invent anything you want? F star x would work, wouldn't it?
But isn't it just f prime of x? Because, I mean,
No.
isn't it just f of x because you're starting with the prime and you're reversing it?
Yeah, but this was never called prime. In other words, that original expression right there was just the expression. There's no reason to call it a derivative. Does that make sense? So yeah, you're right, and it shows you understand the fundamental theorem of calculus, that basically it's kind of directional. It's kind of like if you're standing there, you can walk forwards and take derivatives repeatedly, as many derivatives as you want, or you can walk backwards and take integrals as many as you want. You can sort of go forever in each direction. But if I called that original function f of x, as we often do, if we just walk up to some function and say, hey, look, there's an equation sitting there, then we say, oh, well, that's f of x or g of x or something like that. But if I've taken the derivative, we have a nice symbol for that little f prime or g prime or whatever. And that's a super simple, super easy. In my mind, it would make a lot more sense if we came up with a symbol that was really similar, like f star x, or we can't use f double prime x because that was a second derivative. But, just think about your keyboard. Like, what other things could I like integrals. I'm going to say f money x. I mean, I don't know. What are we going to call it? In my opinion, mathematicians made kind of a mistake here, because a little symbol there would have alerted my attention to the fact that there'd be something cool. Does anybody know what the official symbol is in a math book for that? The answer is capital F. Capital F means if the original function was lowercase f, which is kind of the way you often write it, then capital F means, hey, I just went the other direction. I don't like that because capitals and lowercases often look the same. I personally write in all caps, and so I have to work at it to write a lowercase f. I have to think about it. So to me, that's a lame solution. Like, it doesn't draw my attention to the fact that something just happened there. I think some symbol like prime would make a lot more sense. And so you have problems in your book where it'll say like capital A. And so that means, oh, that equation that I'm looking at there is an integral. In other words, this is an area finding equation. Do you understand that? So lowercase f was the original equation, and an integral is sort of an area finding equation. Now, the one thing I like about their symbol is the fact that it's still an F, because does it make sense those two F's are related? It's not F is one and G is the other, like they're totally unrelated. They're both F, just like F and F prime. Those are still F's. And so one is a derivative or, came from the other one. The problem here is if you wanted to go backwards again, you don't have any new symbols. Like if it had been F star of X, then you could say F star star. There isn't a reason to take more than one integral. You'll be thankful to know. But that's kind of lame. You agree with that? I mean, I guess I'm trying to convince you of my philosophy on that, but that seems a little weak given that really, there's a lot of choices for art. And by the way, you don't have to pick one of the things on the keyboard, make your own up.
Yeah, it kind of seems like mathematicians just choose whatever sort of symbol will be the most confusing to non-math people.
That's so true. Well, and the other thing that's kind of funny is in kayaking, the first person to run a rapid, if there's like a real scary rapid and somebody decides to run it, then they get the privilege of naming it. And that's probably to some extent what happens in math too. In other words, the first person that treads on this path, maybe they're a little quirky, and so they name something a certain way, and it's like, well, they invented it, I guess they should get to name it. Maybe that's what goes on there, but I really don't like that. And if it wasn't for the fact that that's in your book a lot, I probably would make my own up right now and tell you that, so that you didn't walk into the world thinking everybody understood your symbols when they don't. Notice the limits of integration in this problem are missing, like there's no numbers there. So do you understand when I write down here that this is an area finding equation? We just haven't decided where do you want to find the area. Remember, that'll find the area between any points, and we just haven't done it yet. Mathematicians say that this is an indefinite integral, which really just means undefined. It's not defined yet. We haven't decided. So it's already defined some areas for us, and we're just sort of not doing it yet for whatever reason. Which is ultimately good. And as Vale wisely pointed out yesterday, you may remember that it is also true that you can, and you might miss some questions in my open math as a result of this. Remember from yesterday's discussion, there could even be a constant added on to the end of that, like +9 or +12. And it says plus C, meaning constant, because there's no way of knowing what it is. Do you understand that? And if we did, and I showed you this yesterday, if we did use a definite integral, meaning we actually are trying to find an area, you can just pretend that C is 0 because it ends up not making any difference. Since that number shows up in the first number and then you subtract it from the second number, if there's an 8 there, then you end up 8 minus 8 and it's gone anyway. So it doesn't matter if it's a definite integral. If it's indefinite, technically, and again, it's only mathematicians that nerd out about things like this, but they would say, you know, how -1, you know, because you didn't point out that there's a constant on the end. And as I also mentioned yesterday, there are applications where that's pretty cool, actually. So they're not wrong.
I have a quick question.
Yeah, go ahead.
Okay, so this is a little bit off topic, but just thinking, normally when I see like normal area equations for like regular shapes like circles and stuff, they're equal to capital A. Is this why?
That's a wonderful question. I've never thought about that before. Huh. I can't say for sure. You're right, though. I find myself thinking area, perimeter, like usually those are capital letters. That's kind of weird. I don't know. Good question.
I was thinking about equations that are already equal to like a capital function or a capital letter. How would you notate that?
Yeah, V for volume. You never see V as lowercase when you're looking at like the volume of the cylinder or something like that. Yeah, maybe. And it wouldn't surprise me if those kind of thoughts are related in some way. Again, that terminology, though, usually doesn't really make a whole lot of difference. The garden variety question, here's a garden variety question for your assignment today. Here's, what would you do with this? And so if I say, I don't know, let's go from 8 to 5. And what if it was like 2x plus 1 times x minus 4? And notice a minute ago, I was kind of lazy and I wrote that. But remember, all of these are heights. And the little dx is the width. You'll never see problems in the book without that little dx. Because we actually kind of don't do anything with it practically, since we're now looking for shortcuts, we don't actually need to use that dx. A lot of times I will forget it, or you might forget it. It's kind of, you know, poor. It's like kind of like finishing a sentence without a period or not starting with a capital. It's like people still know what you mean, but it's just kind of poor form. So I won't screw it up here. When you first stare at that question, notice this is now, because of those limits, a definite, not an indefinite. It is a definite integral. It's defined. It's actually a defined area. It now has an answer.
Couldn't you expand that?
Yeah. Just like last time, you look at it at face value and you say, uh-oh, quotient rule, which was horrible. And now I got to do it backwards. But you can actually divide it and then it goes away. And the same thing is true here. If you look at this and say, uh-oh, product rule, and now someone has to do it backwards, you're in trouble. We'll save that for later chapters. But the fact is, there's math you can do here. Multiply it out, and then all of a sudden the problem becomes easy. Can you quickly do this and check it on your calculator? Get the answer algebraically perfect, and then go to your calculator and cheat. And remember, on your calculator, you can just type that. You don't even have to multiply it out. And you probably shouldn't multiply it out to check it, because that could be your mistake, like you just did something stupid multiplying it out. I'm just going to give you a second to get ahead of me. So let's see, distributive law. 2x squared plus x minus 8x is minus 7x minus 4. Nothing weird. Add 1 to the exponent, divide by the exponent. Add 1 to the exponent, divide by the exponent. Add 1 to the exponent, divide by the exponent. So I've now taken the integral. I've made a new equation using the fundamental theorem of calculus. And this is now the area finding equation. And so if I evaluate that equation at 8 and evaluate it at 5, and as I showed you, when you evaluate it at 8, you're getting the area under the original parabola from 8 all the way back to 0. When you evaluate it at 5, you're getting from 5 all the way back to 0. And if you subtract those two, then you'd be getting the area between 8 and 5. And notice in this case, and do this stuff on your calculator, like don't like type the whole thing. I'm just going to sit here and type 8 in for x everywhere I see it. And I'm probably going to get some fractional answer for this because I got thirds and halves. And so I'm going to get a fraction that maybe involves sixths. And I'm going to get a weird looking decimal that I probably won't recognize. Fine. But let your calculator do the work on that. You should be able to do it by hand, but let's not and say we did. 2 times 8 cubed minus 7 times 8 squared divided by 2. Maybe that 2 is going to make it thirds. Minus 4 times 8. And I'm going to convert that to a fraction just because maybe the homework assignment wants it exact. So I got 85.333, but I converted it to, you all know where that button is in your calculator, right behind math, third button from the top on the left. Convert it to a fraction, 256 thirds. Now I'm just going to say second entry. Right above enter is entry, second entry. It retypes the whole equation again. Or I can just arrow up to it and hit enter. Now I'm just going to go back and change every one of those 8s to a 5. It just takes a couple of seconds, and I'm in no danger of doing something ridiculous, which is, of course, my nature. I got negative 24.16666. I don't even recognize what that number is. Negative. Weird. What, negative? What must be happening if I got a negative area from 5 to the left?
Dipping below 0.
Yeah. So it's always minus, and then I got a negative 145 sixths. Again, I don't want to do that by hand. Notice you're subtracting. That's weird. You're subtracting. Always, you always subtract. But now I'm subtracting a negative, which actually means it's going to be a positive. And so this feels very, very confusing. So what I'm doing in my calculator is I'm going back up to the 85.333 because it's still perfect. I'm not typing 85.333. Or you can go up to the 256 thirds, and I'm going to say plus, and then I'm going to go back up to the 145 sixths. Plus 145 divided by 6. I got 109.5. I sort of got lucky in that when I subtracted those, I got a terminating decimal this time. The other two, I got repeating decimals, and I got lucky and got a terminating decimal, which means I could just write it down as a decimal if I want to, and I'd still get it exact. Unless my open math or somebody said, I don't want it as a decimal, I want it as a fraction. Fine, I'll convert it to a fraction. 219 halves. I kind of like the decimal answer because the graphing calculator, when I check it in a second, is going to give me the decimal answer. So I kind of like having both of them, even if the 109.5 was a bunch of decimals and I rounded it off, then maybe I write an approximately equal to sign. But for me, if I'm on a test or I'm on a homework, I think I'm right now because I know what I'm doing. I understand this, but I just did math for 120 seconds. And so I could easily have done something dumb. So I don't think I'll show you this just in the interest of time, but I'm just going to quickly type this into my, I should show you, I guess. It's just one last time. You should never do any of these without checking your work, I guess is what I'm saying. Don't rely on my open math to check it. Just get in the habit of checking it yourself because it takes so little time. And by the way, I think you can do this in Desmos too. We'll get around to that later. So I don't trust myself to multiply it out. So I'm going to type the whole thing as I mentioned. Don't type the multiplied out answer because that could be your mistake. 2x plus 1 times x minus 4. And the other part of it is, you know, like you, I was sort of surprised. Hey, I got a negative area for that thing. So zoom 6 to give me a standard screen. And so when I see that graph, I think, oh, no wonder I got a negative area from 5 to 0, because from 5 to 0, most of that graph is underground. And so, oh, that makes all kinds of sense. So how come I got a positive area then from 8 to 0? Somebody tell us why we got a positive answer from 8 to 0 then.
Because it's exponentially getting steeper after it goes above 0.
Yeah, that's exactly right. Right here, you got some negative area, but 8's pretty far out here. And there must be more positive area to counteract this negative area over here. And so positive 1. And so I didn't notice anything when I got a positive answer, but it's actually a combination of positive and negative area. And of course, now I'm going to cheat and say second calculate. And if you're lazy like me, hit the up arrow because it wraps around. And I want to find the area under that curve, and it's waiting to say, where would you like it between? And I say from 5 to 8. And not only does it show me a picture, but it tells me the answer. And now I'm right. Now I know I'm right, and I didn't make a mistake. And I'm, in my case, constantly surprised. Oh my gosh, I didn't even make any dumb math mistakes. That's amazing. That never happens. And of course, you can visually see the final answer to this should be positive, because there's none of that part of the graph that's actually below. So isn't it interesting? You're actually subtracting a negative, and you know, it feels very confusing, and yet the visual answer to this is obviously positive. The whole graph there is above the x-axis. So awesome. So in my case, if I'm taking a test, I often ask you, for my sake and yours, on a test to box your answers, I will say at the top. But part of that's for me because I want to grade your test really quickly, and it helps me when I look at all your work just to zoom in and go, there's the answer. And if I see you got the answer right, then I can take a really quick look at your work, which might be to your advantage because I might miss something dumb that you did or something accidental, and you end up not losing any points when you should. But the other part of it is it just allows me to grade it a lot faster. But notice I'm boxing this now kind of with confidence. And a lot of you last term started saying, checked on my graphing calculator, checked with TI 84. In other words, you don't even need to grade this. You're sort of jokingly saying, I'm on, this is it. I know this is right. So that's what you're looking for today, is like algebra. What algebra can you do to take this back to just the basic kind of a power rule problem? Go ahead, Eve.
This is probably kind of a dumb question, but if we have negative area, why can't we just start from the point of which the area gets positive? Like,
Yeah.
why doesn't that work? Because negative area, I feel like that shouldn't be a thing.
Yeah, you're right. Keep in mind, in my opinion, and this is like blasphemous, I should be tarred and feathered by mathematicians for saying this, but I don't believe there is such thing as negative numbers. And when I say that, I kind of mean what you're getting at, Eve, which is negative is just direction. In other words, area is area. Just because it's below some arbitrary x-axis that doesn't even exist out there in the world, you just placed it there, doesn't mean that area is suddenly negative. It's just directional. It's under, in a case of like sea level or whatever, fine. But even sea level, you know, who said that's 0? And you see what I'm saying? Like it's only a reference frame. So, you know, it's just bothering you, Eve, that's a negative area. And that's why there's, in a sense, 2 answers to these questions. There's the net area, which was 109 for this problem. But there's also kind of the gross area. And if you say, I'm interested in, you know, how much seed does it take to cover the grass? The answer is not 109, so to speak. Well, it is in this case, because from 5 to 8, it was all above the x-axis. But if you had some above and some below, does it make sense? It's going to give you the answer of the positive plus the negative. And so, yeah, there's kind of 2 answers to this, Eve. If you say, I just want to understand, you know, the difference between positive and negative here. And so the reason negative numbers exist is just to define direction. So if a football team goes negative 8 yards, they still went 8 yards. It's just 8 yards in a different direction than usual. And so negatives are directional. Negative 20 degrees just means you went 20 below an arbitrary zero that was kind of made up, or at least defined by nature, like, hey, that's where water freezes, but that's not automatically zero. Do you see what I'm saying? That's just where we thought, hey, we interact with water a lot, and when it's zero, then I can't drink it, and that's pretty important, and so we'll call that zero. I mean, there's nothing wrong with that, but you're just bothered by negative numbers, Eve, and that's good, I think.
Okay.
What else? Interrupt, ask questions. And again, I think it's kind of good that I'm making these up. Where did my note go away? It's kind of good that I'm just making these up randomly. Let's do another one. This is the kind of problem that you should be able to solve right now. Let's see, is this a good problem? -7 to -1. And let's make it 3 plus the square root. Doesn't always have to be x. Let's make it t over t dt. Is that a good problem? Before you started, is that a good problem? And actually, I don't mean the equation. I mean the 7 and the 1. What's the normal way to write those?
Supposed to be the small number on bottom.
Yeah, should be the small number on the bottom. Like in this case, the fact that the big number's on the bottom, it's not that you can't ask this question from a theoretical sense, but it's kind of weird to have the big number on the bottom. So I'm going to switch it. I just wrote that down kind of quickly, randomly. So the other problem is I don't even know if this graph exists there. Does it make sense the graph might not exist there? Are there places where this graph doesn't exist, by the way? What can t not be?
It can't be zero.
Can't be zero. Notice I went between -1 and -7, so I missed that zero. So that was lucky. Had I went from -1 to like 3, then it would have went across that place where there was like a hole in the graph. And so there's, there are graphs that are weird. You could say, what's the area under a curve? And, what if the curve looked like this and it went up forever? And you said, I want to know the area under that curve from here to here. Does it make sense it doesn't exist over there? And so that'd be a dumb question. So you can't just pick these up randomly. You got to think a little bit. Some graphs are weirder than others.
Could it also not be a negative number because of the radical, or can irrational numbers exist in this?
Yeah, what about that square root of t? So I just want to give you a second to think about it. So I've done a little thinking about it, but I think I'm okay. I think this graph exists, and I could graph it on my graphing calculator and just kind of make sure the graph is, as mathematicians would say, continuous. Is there a continuous graph above -1 to 7 that I would find the area under? Again, I like it if the whole thing is above the x-axis, just because it looks positive and everything isn't weird, like Eve pointed out. But as long as the graph is continuous and exists, I don't care how curvy or whatever it is, between -1 and 7, then I'm fine.
I think that you would be able to have negative, because there's ways probably to simplify this to where you don't even have the square root anymore.
Yeah, maybe you don't even need this. Again, the same thing is true. Is there some algebra that you could do to this to make your life better?
Well, could you try to like multiply it by t over t, or t over 1 to get rid of the bottom t?
Yeah, take a look at this graph. So this is good. Is my problem good?
Yeah, it's
Well, not from -1 and -7. There's nothing
There's
there.
no graph
Yeah.
from -1 to -7. And again, I purposely made this problem up randomly, and I'm kind of glad this happened. I did not plan this, but it's like, well, that graph doesn't exist over there. So this is not a good problem. This is kind of exactly what I drew a second ago. Now you stop and think for a second. How come it doesn't exist over there? How come there's no places where t is negative?
Isn't it based on the square root and
Yeah.
how it divides out?
That's
Because it
exactly
can't
right.
be an irrational number.
Duh. T can't be negative. I'm saying duh to myself, like, duh, that's a dumb problem. T can't be negative, and so this isn't going to have an answer. This is a dumb question. Now, based on the graph, could I change the limits of integration to make this an okay question?
Yes.
Yeah.
Yeah. Can I go, if I went from 1 to 7, that'd be good. What do you think about 0 to 7?
I
It
don't,
can't be 0 though.
yeah, I was gonna say the same thing.
Yeah, isn't that like infinitely tall? That's kind of weird, isn't it? Let's try it and see what happens. Let's see if it breaks. Let's try 7 to 0 and see if it breaks. So at least it's a reasonable problem. It'd be better if I went from 7 to 1, but let's try 7 to 0 and just see what happens. Just like the other problems, can you divide these by t so that it's not a quotient rule looking problem? If you can't, you're in deep trouble. Today's assignment, you're always going to be able to do something to get it back to a bunch of pluses and minuses, and you can do that here.
Well, it broke my calculator.
Haha.
Said tolerance not met.
Yeah, so it's like trying to find it, and it sort of feels like that might happen because it goes up forever, and so there's not a boundary, so the graph is not continuous. It never makes it to 0, does it? Notice from the original graph, t can't be 0, so it's a little dangerous to include 0. So you cheated, and the calculator said no. Now it could just be that the calculator couldn't handle it, because the calculator is actually doing this with Riemann sums. In other words, it's actually adding rectangles. It's just faster at it than you and I are. So maybe it just broke because it's too much to add. But remember, this is the concept of a limit. And so maybe there is an answer, maybe not. We should be able to see from the algebra in just a second.
I would guess that we would be able to, because even if it isn't actually 0, it's like infinitely close to 0. So we could still, practically get that.
That's exactly right. Yeah. And again, this is the age-old question. If I walk to the wall across from me, by cutting my distance from me to the wall by half every minute, 1 minute later I'm half closer, 1 minute later I'm half closer to wherever make it to the wall. It's not a simple question. Zeno's paradox.
Real quick, does anyone remember what's the antiderivative of t over square root of t? Like 1 over square root of x, is that?
You're making that too hard. Square root of t over t is t to the 1/2 over t to the 1. And what do you do with the statements when you have t to a power? What's the shortcut to simplify that? At this stage of your understanding, you do not want fractions, because fractions are quotient rule, and we're doing it backwards. So you're not going to have problems where you're stuck with a fraction yet.
Well, I was trying to see if there was a way to get like 1 over square root of x so you could do natural log, but I don't know
This
how
one,
that's going to work.
this one is natural log. 3 divided by t is 3 divided by t. You're not going to rewrite that. And if you remember that 1 over t is natural log, then you say, oh, okay, well, I can actually, I don't want to write that as t to the -1. It breaks. That's the one weird special case. T to the 1/2 over t to the 1, you subtract exponents. A half minus 1 is -1/2. And so I can rewrite that expression. As long as this exponent here is not equal to -1, then the power rule will work. In other words, add 1, divide by it. The reverse of the power rule works. It only doesn't work when it's -1, because when you add 1 to it, it becomes 0, and then you're dividing by 0. Any other power works just great.
You know what I realized about Zeno's function is that if you just walk over to the wall, then you get there. So as long as your movement is a continuous function, then yeah.
You get there if you never stop walking. But if you stop, there's always space between you and the wall. And you have to think of yourself, of course, as a point, not a 3D person with a big nose like mine. My nose will make it to the wall.
Well, yeah, but I'm just saying that I can just walk over to a wall, and I'm effectively going through every single halfway point continuously, and so I'd make it to the wall.
Yeah, but you're not walking to it by cutting your distance by half each time. You can interpret it that way, but if you cut your distance by half each time, then you begin to slow down really quickly. Your movement toward the wall becomes imperceptible. You don't just get to walk at a constant pace and smack your head into the wall. If you're
Might
using Zeno's paradox.
we'll talk about it later, I guess.
So 3 natural log of t, there's the integral of 3 over t. Notice the 3 comes along for the ride. If I was to be technical about it, can't you write 3 over t as 3 times 1 over t? And with derivatives, the 3 just comes along for the ride, doesn't it? And then t to the negative 1/2. Let's see, I add 1 to that, so that becomes t to the positive 1/2, and then I divide by 1/2. Again, do not write this sign there. Why do you not write that sign there?
Because we just took the integral.
You just did it. That's an operation. It's no different than add, subtract, multiply, divide. It's an operation. The operation's done, so don't say you still have yet to do it.
Wouldn't it just be a straight line?
Yeah, say that it's done. Or because I haven't cleaned it up yet, maybe just, save it for a second. So I can't do anything else with 3 natural log of t, but dividing by 1/2 is multiplying by 2. And t to the 1/2 is the square root of t. So I could choose to write it like that. You could write it as t to the 1/2. And then now say evaluate at 7, evaluate at 0. Like that's good form.
Wait, so how did you get the t to the 1/2 over 1/2?
Because the power rule backwards says maybe I'll call it the power rule for integrals. It says if you have x to the n and you want to take the integral, you raise n by 1 more power than it was, and then you divide by that power. So I took t to the negative 1/2. I added 1 to negative 1/2. Negative 1/2 plus 1 is 1/2. So now it's t to the 1/2. And then you divide by that power. So I divided by 1/2. Dividing by 1/2 is multiplying by 2. You agree with that? It's weirder with fractions, right? Say again, April.
Sorry, wouldn't it have already been divided by t because it was 3 plus the square root of t all over t?
But I did that. In other words, I said t, square root of t is t to the 1/2, and t is t to the first, and I didn't want that fraction. So I can clean that up. And so just like x to the 7th over x to the 3rd, what do? You subtract exponents. That's x to the 4th. That's what I did. I went 1/2 minus 1, which is what gave me that 1/2. Thank you. Speak up. Slow down. Think. Ask questions. Gives other people time to process and think. So let's see. No problem evaluating that at 7. 3 natural log of 7 plus 2 square root of 7. There's that answer. Minus 3 natural log of 0 plus 2 square root of 0.
It does break.
Is that okay? Is 2 square root of 0 okay? Can you take the square root of 0?
No.
Calculator just says 0.
Yeah, you can. 0. It's okay. 0 is a number. That's 0. Yes. What about the natural log of 0, though? That's not so good.
The natural log of 0 is 1, right?
Natural log of 1 is 0.
Yeah, there's no way to raise e. There's no number you can raise e to get 0.
That's exactly right. This isn't very good in the graphing calculator, but this is roughly what natural log looks like. Natural log actually approaches the y-axis asymptotically. It never gets there. So in your calculator, if you say trace, and then you say, I'd like to go to 0, notice it doesn't, break or say you're an idiot or anything. It just says nothing. I don't know if you can see that. So I said x equals 0. It just says y equals blank. Like you can't get there. And what Felix said is the reason. If the natural log of some number equaled 0, that would imply, hence, since natural log is base e, that would imply e to the 0 is equal to n. Wait, did I say that right? No, I didn't say it right. Fix it. If natural log of 0 was equal to some number, we're taking the natural log of 0, is equal to some number, that would mean that e to the n is 0. Remember, e is just a number, 2.7. Is there anything you can raise that to that gets you 0? The answer is no. There's nothing, there's no number for that. N does not exist. N does not exist. There's the symbol for exist, an E backwards with a line through it. E doesn't exist. So it does break, and your calculator told you so when you checked it. Again, that's above our pay grade. Like, I can't give that question. You're not going to see that in your assignment. Normally, you just be plugging some numbers in. Does it make sense that my open math might want an exact answer and 3 natural log of 7 is a decimal? So if my open math lets you have a rounded decimal, then you might round that off and get a decimal. But if it wanted it exact, then you might have to leave some natural logs in there. Let's just learn a little bit of algebra here. Let's go back and kind of redo this question quickly from 7 to 1. Notice, as I said before, again, I kind of got lazy and left the dt off. You know, there should be one there. I'm not going to ding you for that. And then here I did it really dumb and wrote dx when the letters were t's. So we said that was really 3 natural log of t plus 2 square root of t. But now we're going to evaluate it at 7 and 1. And of course, it would have been, since we're taking a square root, it would have been really nice if I picked perfect squares, wouldn't it? Maybe I will. Maybe I'll change it. This would have been a better question. And as a, you know, as a test maker, I'm going to try to be testing you on calculus, not algebra. So if I can pick numbers that make your life easier, I will. So let's see, we get 3 natural log of 9 plus 2 square root of 9. That's nice. Minus, notice these parentheses are very important. 3 natural log of 1 plus 2 square root of 1. So 3 natural log of 9 plus 2 times 3 is 6, minus natural log of 1, Vale reminded us, in a roundabout way is 0, so that goes away. And then 2 square root of 1 is 2, so this is just 2. So then I guess the answer is 3 natural log of 9 plus 4. Like, that's an exact answer. That's the perfect area. Are you going to see that if you cheat on the graphing calculator? No, you're going to see some decimal, and you're not going to look at it and go, isn't that 3 natural log of 9 plus 4? Like, you're not going to see it on the calculator. And the calculator can't convert it because it's not getting it perfect. The calculator is not doing calculus like you are to get this answer. It's doing Riemann sums, and it's going to give you an approximate answer. Anybody also know that this is true? How'd I get that?
Did you do something with the 3 and the 9?
Yeah, what's the property of natural logs and logarithms? What can I do with that 3 that's just kind of fun and nerdy?
You can bring that 3 to the front.
It is
I
in
think
the
it's
front.
an exponent, yeah.
Oh, shoot.
Yeah, other way around. Like that 3 can come up here. You're used to it going the other way, like the 3 can pop down front, but it can go up there. Notice that's just a cleaner way to write it. No waste of time. I would hope that if my open math wanted an exact answer, it would let you kind of answer either one of those. For that matter, since 9 is 3 squared, what's another way to write this answer?
Natural log 3 to the 6th power?
Not 6 power, but the 2 can come down front multiplied by the 3 to become 6. That would also be true. Again, these are just cool algebra tricks, and you know, these are kinds of things that might happen where if you cheated and looked online for an answer. You know, you got one answer and somebody else got something else, and you know, having the algebra skill to say, oh, those are just the same thing, like writing.
It would just be bad form to have natural log of 9 to the third power type thing.
Yeah, it's just cleaner. I mean, exponents are weird looking. In other words, if you see 9 to the thirds, an ordinary person has to be told, what does it mean that the 3 is up there, right? Whereas if I write natural log of 729, if you know what a natural log is, that's a nicer, cleaner way to write it. It's easier to type into a, you know, on
Okay.
a keyboard. It's like, you know, my overall answer is who cares? I don't care what you write on a test. But of course, again, with this problem, I'm going to want to graph this, and I'm going to want to see what decimal, and I'm not going to do this, but you should be doing it right now. I'm going to graph this original problem and ask the calculator what's area it is, and it's going to give me some decimal, and then I'm going to look at my answer and I'm going to change it to a decimal and hope they're the same. If they are, oh, cool, got it right. If not, made some math mistake. What about this? I'm stealing one from some book somewhere. And the reason I'm stealing this from the book, because I'm assuming that they nerdily made up the problem to work out really nice. Remember, you have to be given questions very carefully in this assignment. No fractions, oh, awesome, don't have to worry about that. No multiplications, awesome, don't have to multiply anything out, but I do have trig. Fortunately, what's the integral of cosine?
Sine.
Sine. The integral of cosine is sine because the derivative of sine is cosine. That's the reason it is. Fundamental theorem of calculus. The integral of 1 is x because the derivative of x is 1. Derivative done. Now evaluate at pi over 2. And you can see why a book would pick pi here, because sine of pi values give us perfect answers. Whereas if I evaluate this from 2 to 3, it's not going to be a perfect answer. Should be able to do this in your head. Pi over 2. Let's see, where am I? Oh, I'm up there. Negative pi over 2. Oh, I'm down there. Sine is giving me which coordinate of those points?
The y coordinate?
Sine is the y coordinate. That's exactly right. So I need the y coordinate. So that means the sine of pi over 2 is 1. So that's putting pi over 2 in for x here, and then this just is x. It's always minus. Now I'm going to put in pi over 2. Sine of negative pi over 2 is apparently negative 1. The y coordinate of that point is negative 1. Again, you can look at your cheat sheet for trig. You can just type sine of pi over 2 in your calculator, although you got to realize, oh, I'm in radian mode. And then this is a minus sign. But then I'm putting in x is negative pi over 2. It'd be really easy to do something silly there. So let's see, 1 minus pi over 2, minus a minus 1 is plus 1, minus a minus a minus. Woo! That's actually plus pi over 2, but then it's minus, so it's minus pi over 2. So 1 plus 1 is 2, minus pi over 2 minus another pi over 2 is minus 2 pi over 2, which is minus pi. I think that's the answer. That's the kind of question you're going to see in the book. They probably would want an exact answer because notice they made it up in such a way that that wasn't horrible. Not going to show you just in the interest of time, but I'm going to quickly go back and say, I'm going to type the graph y equals the cosine. Do I have to be in radian mode or degree mode here? Does it matter? I'm thinking out loud. I actually don't know the answer to that yet. I'm just posing it to myself. Cosine of x minus 1. I think I do have to be in radian mode. Unfortunately, I'm teaching engineering this term, and we're always in degree mode for that class. So I graph this thing. You should not be surprised after the fact to say, oh yeah, cosine graph minus 1. Oh, yeah, that'd be a cosine graph, but it would be slid down 1. So if I say second calculate, what's the area of this thing from positive pi over 2, pi divided by 2, to negative pi divided by 2. I get that area, which is clearly negative. Sorry about the focus. Then I got 1.1415. I think. I'm not sure that's what I got. I'm a little.
That's what I got before I converted mine to the exact answer.
Shouldn't it be negative?
Yeah, I got negative 1.415.
Mine doesn't say negative. I don't understand why. Well, I'll figure it out later. Notice I didn't think about this at the time, but 2 minus pi. Hey, pi is 3.14. 2 minus 3. That's a negative number. So, I don't know if I would have recognized it, but, then I type 2 minus pi in my calculator. I get the same decimal. And now I think, okay, great. I think I got this right. That's the lion's share of what you need. And now let's just go back and take a quick look at some of the, I don't know, curveballs of this section, if you will. Let me see. Kind of want to look at the assignment questions. I think I'm gonna stop sharing for a period of time here. And I'm gonna share my regular screen. Bring up my open math, and I'm actually going to bring up the 5.3 assignment. I just want to understand, I just want to know if you can interpret the goofy questions that this starts off with. Let me first go down to the normal questions. These are the questions that are the only ones I really care about. They're just asking you for an integral. Notice every one of them is a definite integral. Notice some of them are using the symbols. The integral from pi to 0 of 4 sine of x dx. But then this one says find the area under the curve y equals 7x cubed over the interval 0 to 2. Same statement, they just put it in words, right? Just didn't use the symbols. 1 over x squared, is that logarithm?
Nope.
Let's see, yes and no. If I was to write that without a fraction, that'd be x to what power?
Negative.
-2.
-2. There's no reason you can't add 1 to that and divide by it. It won't work if you do logarithm. Logarithm is only 1 over x, not 1 over x squared, not 1 over x cubed. That's a bit of a curveball. So most of these are just good, straightforward questions. Things that we practiced. What about e? There's e in there. What about not just sine of t, but sine of 2t? You got to think backwards. Like, what did we do when there was a derivative? Think chain rule. What did we do when there was a derivative and it was the sine of 2t? I want to let you think about that. Here's one where you got to multiply things out. Here's one where you got to divide some things. Most of these questions are pretty good, straightforward questions, but these first 3 are a little weird. So let's just actually first 4. Let's just stare them in order because part of me didn't want to assign them, but what's with this? F of x. Notice they gave it a name. And notice they didn't say the equation is f of x. They said the entire integral is f of x.
So does that mean once you find the integral that it's f of x, or?
So what does an integral tell you again, generically?
Area under a curve.
Area under curve. So that means, since they gave it a name, then that means f of x is the area under the curve. F of x is a brand new equation that tells you the area under this t to the 5th equation. Notice there's 2 different letters there. Did it have to be 2 different letters? No, except for then they did something weird here. And they said, let's evaluate this not from like 7 to 3, but from x to 3. Does it make sense? You're going to plug in x for t, and you're going to plug in 3 for t, and you're going to get this an equation that has x's in it instead of just a number. You're not going to get a numerical answer. You're going to get an equation with x's in it. Oh, no wonder they called it f of x then, because it's got x's in it. But it's kind of dumb. Wouldn't you agree?
It's a little confusing, but
Yeah, but it's there, and overall, I don't know, glad it's here because it does force you to understand what is it I'm doing again. At your first glance, you should stare at that and say x. Like, what are you talking about? Well, I mean, if there's a picture of a rabbit there, plug the rabbit in for t. Like, yeah, you don't understand what it's getting at, but plug it in. Like, don't. It's just because it's not a number. You should actually be happy because when you plug a number in, you actually got to do something. 2 to the 6th is a number, and I got to figure it out. X to the 6th, x to the 6th. I'm done. In a sense, then, what is this giving you? What is the whole thing here? It's telling us the area under t to the 5th.
For any interval from 3 to x.
Exactly, from 3 up to, well, whatever the heck you want. So it's like now you have an equation that tells you the area for any area under that t to the 5th equation from 3 up to whatever the heck you want. So you don't have to, you've solved like hundreds of problems now instead of just one. All you got to do is throw in x is 7 or x is 2 or x is 9. So it looks weird, but that's not that weird. What about this one? Whoa.
And how do we approach, like, what does the f prime of x and stuff mean though?
Yeah, thanks for pointing that out, Felix, because I just looked at the problem and didn't really look at what it asked down here. F prime. Wait a second. So if f of x is this, and I figure this out and I get some equation,
then the derivative of that would be the f prime of x, right?
yeah, so you're going to get this equation with a bunch of x's in it, and then they're saying, now take the derivative of it. And the reason they said fundamental theorem of calculus is because first integral kind of goes one way, and then derivative says take it back to where you started again. It's kind of like multiply and divide. If I take the number 3 and then I multiply it by 7 and get 21, but then I divide by 7, I get back to 3 again. Multiply and divide are inverse operations that undo each other. Derivatives and integrals are inverse operations that undo each other. And so they're saying, you know, again, this is just a dorky exercise. In other words, now you got this f of x equation. Well, then don't just report it. Tell us what the derivative is.
What does that mean though?
Yeah. What does it mean? And I'd encourage you to think about that. Is this a dorky exercise? Which is fine. They're just making me practice, making me understand the language of calculus. Or does this actually tell me something? Is there something that would tell me about this original equation? Play around with that a little bit. I don't want to answer it.
I got it, but I just thought it was a mistake. Like they forgot to use T as the answer
Yeah,
for the variable.
right. Yeah. Which, again, I want to remind you, you guys are the guinea pigs here. You're getting this class way cheaper because you didn't have to pay for this program. But there can be bugs in it a little bit. I mean, I've tried to work through and make sure, me and one other person, so it shouldn't happen very often. But if a problem is broken, I definitely want to know, because then we can fix it for you and for future classes. What about this one? Fundamental theorem of calculus. The integral of t squared, the area under a parabola from 16 to x. So again, that's weird, 16 to x. But then outside, what are they saying to do with it? That answer?
Find the derivative.
Find the derivative. That's another way of saying take the derivative. It's actually the same thing they set up here. In other words, get this f of x equation and then take its derivative. This is saying exactly the same thing. It's saying take the integral of this. Because it's not numbers, you're not going to get a numerical area. You're going to get an equation that's got an x in it. And then they said take the derivative of it and then tell us what that is. Do you see that's practice for the fundamental theorem of calculus, which says these two operations are inverses of each other. If you take the integral and then you take the derivative, you kind of got back to where you started again. So the question is, will you get some kind of t squared equation again?
So can you just like cancel those out or something?
I would say yes, except for the fact that you are plugging in a 16.
I see.
If I said, what is the derivative of the integral of x? Generically, you'd say x. Do you see what I mean by that? Keep it simple. Don't plug anything in. It's an indefinite integral. If you take the integral of x and then you take the derivative of that, you're going to get the x back again. Or in the reverse order, what if you take the derivative of x first and then you take the integral of that? What do you get? You get your x back again. So you're kind of just playing around with the fundamental theorem of calculus. What about this question? Again, this is mathematicians being, somebody should control you. This time you don't get an equation. What does all this junk mean up here? F of x equals, what does all this mean? You should be able to interpret this. Like you probably haven't really seen this that much before, and it's pretty darn irrelevant, but what is that saying?
It's just telling you what x is in different situations.
Yeah.
It's like narrowing down, right?
It's telling you what y is. Remember, f of x is y.
Oh,
Four
yeah.
different x's. And so here it says if x is anything below -4, like -5, -6, -7, -8, then you get a y value of 0. Can you graph that?
Yes.
But what if x is bigger than -4? Well, then you get a y value of 4 suddenly. So it's kind of cruising along at 0, and then suddenly it's 4. And it's always 4 whenever x is between -1 and -4. But then when you get up to -1 and all the way up to 3, suddenly you're down at -2. So you know you got a horizontal line at -2. So it's kind of this graph that has like these steps in it. Does that make sense? So can I find areas under those? Well, yeah, it's just rectangles. Again, I haven't read the question yet. Down here, they say that g of x is equal to the integral of this equation up here. And notice again, it's an integral of f of t, which is weird because there's no t's, except for then they're saying, hey, plug x into it. So I'm going to get an equation with an x in it. So what is g of x then? What does g of x tell us?
The area under the function.
Because g of x is an integral of this equation up here. It's telling us the area. So it's asking about the area underneath some lines. Does it make sense you don't need an equation to find that area because it's lines? Like, would you, and again, I'll just ask you rhetorically, would you have been able to reason that through for yourself? Maybe I shouldn't have said anything about it. Maybe I should have let you stare at that. How quickly would you have given up? Would you have assumed, oh, I can't do this, it's confusing, I need help? And maybe you would need help, but would you stare at it a while and try to figure it out? Down here then, what is g of -3 asking? What's it at? I don't mean what's the answer. What is it asking?
It's asking for the integral when it's 3.
Yeah, and notice that value of f
-3.
is -3. And notice if you put -3 in up here, there's always a -4. So it's saying, what's the area under this curve up here from -3 to -4? The -4 is fixed, but the x is not fixed. And so sometimes the x is -7. Sometimes it's like, you can actually draw pictures of this, and as stupid as this question is, or as weird as it looks, and it certainly has no bearing. I don't know. I guess maybe that's an overstatement. It doesn't really feel like it has a bearing in the real world. Whatever, I can answer it.
I mean, it makes sense. You just gotta, you know, like tap back into brushing the webs off those, you know, how things are written in algebra. Yeah.
Yeah, that's right. And I've never seen this before either. Like, I purposely didn't look. I remember just glancing at these and going, "Whoa, what the heck are they asking there?" And I purposely spent no time trying to figure it out, because I kind of like to try to figure stuff out in front of you, just to show you that you can reason about things, and like, you can do it. So here's one other thing. What is this statement up here? I'm not going to say much about this because I want you to figure this out yourself, but I'll just remind you of one thing.
Isn't it the step up from an integral because it's a capital A?
Yeah, notice in a sense this is a good place to capitalize, because if this equation is equal to an integral, then that is an area. And so A for area and capital A, in a sense, that's good form. Again, I'd be much happier if that said something like F star of T or something of that nature. But again, notice you're plugging in X and not a particular number. So A, capital A of X, is telling us the area under this curve. And so notice, just like in this last problem, we didn't have an equation, but we had kind of a, I forgot what this is called, a piecewise function that told us the Y value for different locations. Well, here we have a graph. So I'm not going to plug anything in. They're just wanting to understand, can you find the area under that? Now notice they're asking about what value of X does A of X have a local maximum? Is this graph A of X here?
No, that's F of T.
This is F of T. That's a local maximum right there of F of T. What is A? It's the area.
Wait, that says that's f of x.
It's 4, right?
Yeah, this is F of X or F of T.
But isn't x the from like this from the range from 0 to x or something?
That's exactly right. 0 to X. And so this 1 and this 2 and this 3 are X's. That's exactly right. And so I think you're right. An argument could be made. And notice they even said here with F of X shown in the graph. So because you're plugging in X's, you're exactly right. Felix, these are X's, not T's. So what they're asking about is the maximum area. In other words, if you go from 0 to 1, is that the biggest area you can get? If you go from 0 to 2, is that the biggest area you can get? Again, kind of just a weird question. These are all introductory, irrelevant questions. I'm not asking anything like this on a test, a quiz, like these are, but you know, thinking related questions. Then you get into the garden variety type of questions in the assignment. But I guess what I want to, the reason I kind of elaborate on that a little bit is because I don't want you to swirl too much in the homework, but also because I want to convince you that just because you first look at something and think, I don't understand what that's asking, doesn't mean if you don't put your mind to it, you could figure it out. But like Justin said, you got to go back and brush the cobwebs off of the language of calculus. You got to know that F of X is saying Y for some given X. That's got to mean something deeply to you. Otherwise, you aren't going to make sense of these weird questions. Well, I wanted to spend part of today on 5.3 and part on 5.4, but now we have 3 minutes. So I think I'll look at the syllabus really quick and see what I have planned for next day. 5.3. Yeah, we're fine. We'll basically just spend one day on 5.4 tomorrow, and then we'll be done with 5.4. So I think we're okay. I don't think I'll start anything else. What else? For the good of the cause. All right. Get yourself out of here. This is a very rare day. You're out of class a few minutes early. Stay after if you want to ask questions. Otherwise, I'll see you tomorrow.
Thank you.
Thank you.
You.